Hi everyone, welcome back. This is question 2 of the May-June paper 2. In the previous video, we looked at question 1 with the algebra and how to answer those questions. Now we're going to look at sequences and series. You can see the first one that we are tackling here is then going to be a geometric series. So geometric series, there's a few things that we need to consider. We are going to work with a constant ratio there. And then we are also going to work with an a value, which is then my first term in this case. But then let's quickly have a look. So it says now, it asks there first, is this a convergent geometric series? So they are asking, does this series converge as we go to infinity? So if we infinitely add values, is there a number that is going to represent if this converges? And there is a certain test for that. To test that, we need to know, is my R value, my constant ratio, going to be smaller than 1 and greater than -1? And to calculate my R value, to know what my R value is, my R value is going to be term 2 divided by term 1. This is important because we need to now determine what is my ratio. So let's quickly have a look here. So first of all, we need to go and determine my R ratio or my constant ratio. So that means term 2 divided by term 1. Term 2 will then be the 1 over 15 that I have there. So 1 over 15 divided by, and now we're going to look at the term 1, which then is 1 over 5. And if we type that into our calculator, we get an answer of a third. So now we need to go see, is this value, so is 1 over 3 smaller than 1 but greater than -1? In this case, yes, it is. So I now know that this series will converge. So that means I need to conclude for the final mark there that it is, therefore, it is convergent. And that is important. You need that conclusion for your second mark there. So now we already got the answer for convergence. And let's have a look at 2.1.2. And we touched quickly on sum to infinity. So we know that the value for sum to infinity converges at 1 over 3. So that means we need to substitute in 1 over 3. So to get that answer, we need to say that sum to infinity is equal, and this will be on your formula sheet, is a divided by 1 minus r. We already determined the r. We want to see what is the sum to infinity if that is the value. Remember, my a value is term 1. So I'll make a note here. A is equal to term 1. Please make sure of that, that you can substitute in the correct value. So that means I have 1 over 5 divided by 1 minus a third. And that answer will then be equal to 3 over 10. So this means the sum to infinity, as my formula or my series converges, it will not be greater than 3 over 10. Let's quickly have a look at the next one. So for 2.2, it says an arithmetic and geometric sequence are combined to form a pattern, which is given by Pn equals x a third, 2x a ninth, 3x and 1 over 27, and so on and so on. So here we need to immediately go and highlight that these are all represented by different terms, because this might help us in questions to come. So now that I have these different sequences or series that I have here, I can now answer questions if they come up where they only want to focus on x or on my 1 over 3, 1 over 9, 1 over 27. So important here is this will now, if I make a note there, this will now form my odd terms And the pink there, which I will put there in green, the pink will then form my even terms. So that means T2 will be a number value and T3 will then be a variable. So that is important to note. So the first question, easy, write down the next two terms. So we can see that it goes from x to 2x to 3x. So that means I'm adding x every time. So now I can see that the next term definitely has to be 4x. And to go from a third to a ninth, I basically say 1 over 3 times 1 over 3, which is equal to 1 over 9. So that means I'm multiplying with 1 over 3 every time. So if that is the case, then I can say 1 over 27 times a third will give me the next term. And then 27 times 3 gives me 81. So the next term is then 1 over 81. So that is important to note when we start tackling these questions. Then for 2.2, determine the general term Tn for the odd terms, and now it links to what we already indicated, to the odd terms of this pattern. Write down your answer in terms of x. So we need to go back to our standard equation. So the standard function is then, let me just write that down for us first. So we have x, 2x, and 3x. So that is our terms that it will form. So remember, that's not every second term. So that means Tn is going to be equal to a plus, and then here we have n minus 1 d. Now all we need to do is we have to substitute x. So a represents my first term, just as I showed you previously. So that means I will have x plus n minus 1, and then d is my constant difference. So every time I'm adding x, so therefore that will become x. And now I can then continue with my equation, and that will be equal to x plus, and this would be nx minus x. So all I did there is I distributed my x value. So my x's will cancel out. X minus x is 0. So therefore the Tn is going to be xn. Now they ask, calculate the value of P26. So the key thing here to remember is, and you'll see I'm highlighting that in pink, P26 is a even number. So if that is an even number, I need to remember that I'm actually going to be focusing on every second term. So that means I have to take that 26 and divide that by 2. So that means I'm going to focus on 13 terms and not 26 terms, because the terms in between are my arithmetic sequence terms. So let's continue. Now I'm working with a geometric. Then first I need to go and calculate my a value. My a value for that term is, and I can write that down for us first as well, is we have a third, a ninth, and then a 27th. So that means my a value is equal to a third. And now I need to calculate my r value. Remember, r value is then going to be T2 divided by T1 to get my constant ratio, which means then I have a ninth divided by a third, which is equal to a third. I have my ratio now. So now I can just do the substitution. And the important part is I need to go get what would be T13 specifically for that sequence, because everything in between those would have been my arithmetic. So when we look at this, it would be T13 is equal to my a value, which is then a or n minus 1. So my a value, which is a third, multiplied by my ratio, which is also a third. And then remember now that I have my number of terms, which is 13 minus 1. And that we can type into our calculator. It will give us quite a big number. And that answer is going to be equal to 1 over 1594, 3, 2, 3. All right. So that would be the final answer for this question. Okay, so the key thing for this question was that you needed to note that I'm working with 13 terms, so every second term on my even scale, and then I need to go and calculate my A value and my R value. Now, if we look at 2.2.4, we can see that the sum of 21 terms Pn is equal to 33.5. Then they ask to determine the value of x. So we now remember that our equation was, or our sequence was x a third, 2x a 9, 3x, and so on and so on. The blue was my odd numbers, the pink my even numbers in terms of my sequence terms. Now, if we now look at this, I can determine and say that I need to know that in the two sequences, the sum of the two will give me 33.5. So therefore, the sum of my odd numbers plus the sum of my even numbers is going to give me that value. So if I then start with the sum of 11, which is my odd numbers, plus the sum of my 10 even numbers, so this 10 plus the 11 gives me my 21 terms, and now I just need to know which one is which. So if I look at the blue here, the blue represents my arithmetic, and the pink here represents my geometric. So now if we look at that equation, the equation for arithmetic is then going to, the sum for an arithmetic is n divided by 2, and then I have 2a plus n minus 1 d. So that will be for my first 11 plus now the sum of my geometric, which is a r n, r to the power of n minus 1 divided by r minus 1. That is the sum of my geometric sequence. Now let's quickly have a look at the rest of these values. Now all I need to do is substitution. So I'll do 11 over 2 times, and now 2x, and then the n minus 1d, d is also x, so therefore I can say 2x plus 10x. Remember, n is 11, so 11 minus 1 gives me 10 times x, which is 10x, plus my a value, which is a third, my constant ratio, which is also a third to the power of 10, because I have 10 even terms there, and that is then subtracted by 1 divided by a third minus 1. Now I can simplify. If I simplify this, I get the first part there as 66x plus, and if I type that into my calculator, I get 0.5. So let me just highlight that. So I have this part here, which is my odd numbers. So the odd numbers that I added all together, so the sum of my odd numbers plus the sum of my even numbers, which were my geometric sequences. All right, so if I then add that, I need to remember that this is all equal to 33.5, because they say that the sum of all of this is equal to 35, so, or 33.5. So now I can solve this by saying that 33 equals 66x, and now I can say 33 divided by 66 equals x, therefore x is equal to a half. Alright, so in the next video I will be looking at question 3. Question 3 will also be about my sequences and series, but now I will be looking at quadratic equations and how those questions can be asked in question 3. Please like and subscribe, and please comment on any questions that you have, or any videos that you would like me to make in the future. Thanks for watching, and until next time.